Hey guys, today we're talking about forensic anthropology. So we're looking at bones and what can we get from them forensically speaking. So at some point, I'm going to have you guys watch a bones episode, but we haven't yet. So disregard the slide at the moment. But we'll go back and talk about this at some point. Okay, so first question: what is the role of a forensic anthropologist? So I want you to think about it. And a lot of you guys, the first answer you'll come to is death investigation, right? How did somebody die? And who is the person, right? Identification. There's another big reason that forensic anthropology is really necessary. So think about it for a second so you can help with it. All right, and it's to track anthropological data. For example, the height of the people in this area. People indigenous to this region, are they shorter than normal? Are they taller than normal? Over the years, have people started to shrink? And so these are the type, different trends that anthropologists like to look at. So that's one of the big things, one of the reasons we have that. So for history. So when you look at a skeleton, what can a skeleton tell us? So think about right now, what do you think you could get from skeletal remains? And you might have seen cases before or read about different court cases where they use bones to figure out things. But from what you know currently, what you think you know, see if you can make a list of things that the bones should tell us. Okay, and I made a list myself, and there's about 7 that I think specifically we can get. Okay, so here are mine. So we know that we can figure out if it's a male or female, the sex. We know that we can figure out the height. And again, you would never say a person's 6 foot tall. We would always give a range, like they're between, 5'11" and 6 foot. Or, the range doesn't, there's no specific range it has to be, like, how many inches or whatever. But there is a plus or minus factor that you're going to see when we do calculations for our own heights. And we're going to calculate using our actual bones and put them into the equation and see if it works. That's what we're going to do next class. Age, so we can tell by wear and tear and different things like that. We can tell by age. But then if we go to living conditions, if somebody's living conditions are more harsh than someone else's, you might age them older than they are, right? If somebody works on their feet all the time and maybe they have bad knees or something like that, they may look like they're older than they are, which is why it says some are tough. Also, if somebody's an athlete for years and years and years, and they have an issue with a certain part of their body, whether it's the knees or shoulders or something like that, then it's gonna be harder to age them. For race, so tell me why you think race has become a more challenging um, attribute of a skeleton in recent years, and by recent I mean last, I don't know, 1,000 years. So I'm going to tell you, it's because we have a lot of mixed races, right? So we can't just say, when we talk about forensic anthropology, we talk about three races. We talk about Mongoloid, Negroid, and it's European. But I think sorry, I thought this stopped sharing for a second. And so they don't have a mix. So, most of us are mixed races. And so you would just look at the defining features on that person and say that they're possibly part this, possibly part that. So, again, you would never be able to say, somebody that's a Hispanic race is very hard to sex or race on the skeleton. It's hard to tell because there's so many different type of Hispanic people out there. Somebody that's negroid is a little easier. I'll show you when we look at the skulls. You're looking for one specific thing that a lot of the negroids have. Actually, there's 2 different things I can show you on that help you see. But again, if somebody's a mixed race, they may not have all of those. Those may not all show, be accurate in the bones. So we'll look at them. Living conditions. Do you take care of yourself? Do you eat healthy? Are they deficient in certain minerals and stuff like that? We can see that in the bones. Do they have a disease, like an old school disease, a bone disease would be like rickets, something like that, so they can test the bones and be able to figure that out. Are they from a specific area where these people are shorter than normal? Like, for example, you could have like pygmy tribes in different places where they talk about they're a lot shorter than normal, and also they have sometimes their hips make it look like they're polymorphic. You can't tell if it's a male or female because they don't have the normal traits that a pelvis would have. So different things like that. Other things and traditions, you know how people like in, I think it's China, where they wrap the feet to bind the feet to make them stay shorter. That would be something you'd see the smaller feet there. And another one, I don't know if you guys ever saw that, like that Crystal Skull movie with Indiana Jones. They when they wrap the heads and they make the heads really squished. That was like a thing in the Mayan culture. So I'll show you some skulls like that when I'm talking about this in a picture in a little bit. So we can get a lot of things from the bones. So something you may not know is that when uh, um, the police a lot of times get bags of bones, they find them, like people find bones in their backyard, and they go to the police and they go, "Oh, are these? What are these bones?" And a lot of people think they're human bones, and almost a lot of the time it comes up that they're actually animal bones, which makes sense. Somebody buries their pet in the backyard, or an animal dies in the woods, whatever. And it actually is cited that 25% of cases that the bones that are brought to the police are not human. And so that's very common because there are very similar animals. For example, overall, the animal that has most similar bones, like in general, would be a deer, which you may not think. And then some other ones have similar, bones. Like for example, a raccoon. The raccoon's paws look like a kid's hand, and then a bear paw can look like a human foot or a human hand, depending on which one it is. Um, the femur looks very similar in an animal, but the femur in an animal is usually a lot shorter. So that's one way to tell. But the big thing is the animal bones are different shaped. Like you can see a pronounced shape in ours, whereas the animal bones are more cuboid, like they have more edges to them. They're not just rounded. I'll show you in a picture in a second, but that's one way to tell. And sometimes you can't tell. And so when you can't tell, then you have to go to the microscope. And so you have to look at it under microscopically and see what the cells actually look like. And then you can really tell. It says bones of infants or young children are even tougher. Why is this? Well, you guys know we have over 200 bones in the body, but when you're a baby up to the age of like 2, um, well, lots of their bones are not fused. And so if a baby dies in the skull, even there's all kind of fissures and stuff like that, and that are not fused all together. And so if the bones are there and the cartilage all goes away, it's all these little pieces of a skull. So it doesn't look like a normal skull like we're gonna look at today. So I think it can be harder if you don't have all the bones of the infant skull, but it also could be easier if you have all of them right there and you can piece them together and be like, oh, okay, then this person was 2 or under. You see what I'm saying? But if you don't have all the pieces and some are missing, then it might be hard to say. The other thing is when you don't have a whole skeleton, it is a little harder to determine if it's male or human or animal. But again, you can always take part of it and look under the microscope and see what the cells look like. Okay. So look at this right here. This is my favorite part, is looking to see, is this human or animal? So these are mandibles. So the mandibles look fairly similar. On the one on the left, it just looks like it's missing some teeth right here, like on the top, like maybe some teeth should be right here. This should be obvious to you guys that that's a human, but this right here is a deer. So it does look pretty similar to a human, right? And so if you might see that in the woods, you might freak out and be like, oh my gosh, that's a human mandible, but very similar, but not quite. Here, one of these is a bear and one of these is a human. So take a look at it. What do you think? Okay, so upon further inspection, you should realize this one on the right here is a bear, and the one on the left is a human. Okay, we have that more curvature of our fingers, like when you hold them, and they don't usually not perfectly straight like this guy is. So that's what that is. How about these guys, human or animal? So this looks weird on the left here because we're missing part of it. But as you get older, when you're younger, this doesn't have to be fused. The epiphysis, which is the end of the bone, could have a piece of cartilage in between. So if that cartilage wears away, that piece would be separate from it. The epiphysis would be separate. However, this also looks like it's broken. So this right here is actually a human femur. Okay. And you can see I have one here. So it does look similar to that, a human femur. And I can see it's a really long one, so it's hard to see all of it. But it's just what it is this is broken off of it, and that's why you can't see. So it's like this. This is all you see of it, right? And then on the right hand side, this is hard to tell, right? You have a lot of these bones, but this is what I'm talking about the weird shapes. You might think, oh, these could be human ribs, but if you look at them closer, do you see how they're like really thick looking? And you might have ever noticed this type of thing when you're eating ribs, because these are ribs, but these belong to a hog. And so they definitely have bigger ribs here than we would have. Ours are much more thin, and they get kind of thin as they go out, you know, in the edge. So those would be a hog. That's an animal. All right, take a look at these. So remember what I said, the femur in a human is definitely longer. So it's obvious, it should be, that these guys are human femurs. But what about these guys? They look very similar. Look at the width. Do you see how these, like, they still look kind of bulky? Like, would you think that these femurs would belong to kids? Okay, the answer is no, because a kid's femur is going to be a lot thinner than that. And so these are probably some type of dog or some other type of animal. I don't remember which animal they are, but all these four are animals. Okay, how about here? So this is a little harder. We're looking at mummified remains in this case, a little different. All right, so the one left, the two pictures on the left, sorry, these are supposed to be feet, right? So this one right here, this is a human foot, right? You can see kind of the indentation. It kind of looks more like a human. This is a human foot, and this is a bear paw. Okay, so look very similar. Like if you found that in the woods and you were hiking and you saw that, you'd be freaking out and a lot of people have. They brought that to authorities, and people freak out and think that that's actually human. Over here, also same type of thing. We're dealing with the mummified remains. This is part of a human foot. Like again, you can see this little indentation here, which is what we have over here, and then this is a bear paw as well. Okay, mummified bear paw. So what if you get pieces like this? Okay, I gotta be honest, I don't even remember. I don't remember if these are human or animal, and so if I got in that predicament, I'd need to know what to do, right? So what I would do is I'd have to get a little piece of it, and I'd take it under the microscope, and I'm gonna see one of these two pictures. If I see picture A, the bone is human. All right, so human cells look like that under the microscope. Animal look like this. Do they look a little different for different type of animals? Yes, but you see how human will always be round and animal will always be more have that square shape. Okay, so that's a really easy way to tell under the microscope. Like I'm not sure, like those femurs back there, the femurs that were smaller versus the one that were longer. If I'm gonna not sure, I'm gonna take a cross section of this and look under a microscope and see what it is. And even if they are sure, sometimes they will do this just to double check, and make sure. Okay. All right, so if we're going to age a skeleton, we're going to look at teeth, right? And let me move this picture so we can see this picture better. So you know, when you were a kid, your teeth come in at a certain age, right? They start to come in. You get teeth. You start to break teeth when you're like 6, 7 months old. You get your first tooth, and then they continue to come in, and you have baby teeth. You have baby, so it's 20 baby teeth you start with, and then as you start to, get in first grade or whatever, you start to lose your teeth, right? And then you start to get your adult teeth or permanent teeth. So this picture always creeps me out, but these teeth here are baby teeth, right? And here's how I know. See the teeth up top? They're like waiting to come in. So when a kid doesn't have their adult teeth yet, they have these teeth up there, like waiting to come down when it's ready. And typically, a child will have all their permanent teeth by the age of 12. So by about seventh grade, you should have all your permanent teeth. Now, wisdom teeth are a different story because wisdom teeth don't usually come in until you're 18, but sometimes they never come in for people. And then some people will remove them before they even come in. Like mine never came in, and I actually had them removed when I was like 22 and just removed them because they were taking up like room in my mouth in the back. So that's something. So if we look at this picture, how old would you say this person is? Well, I can see here, right? They're getting their adult teeth here on the bottom. It looks like they still don't have their adult teeth here on the top, right? So they don't have all their adult teeth in yet. So we definitely can't say that they are 12, right? Because they don't have all their permanent teeth. So I would say that they're, and again, you have to give a range if we don't have exact numbers here. So I would say that this kid is between the age of maybe 5 and 12. You could even go as low as, maybe they have a lot of teeth here, so I'd probably say around between 5 and 12. Okay. A little younger, you could say if you wanted to. So that's how I would age the teeth. That's what you want to look at. Okay, next thing we're looking at. So we're looking at a skull. This is what I was talking about before. When you have a little kid, these suture lines are not completely fused. And so if this child dies in the woods, their skull would be completely apart at those points because there's just, well, at some point there's not really anything, but there's just cartilage between them. And after a little while, the cartilage goes away and that's it. So it says only helpful if a person is under 2 years old or over 35. So under 2, this would be broken apart. Okay. And again, that's what it says here. What would it look like at the age of under 2? Under 2 would be broken apart. Okay, so when you look at the long bones, and I really wish I had one out here, but I'm going to show you this right here. So this here at the end, this is the epiphysis, like the end of the bone, right? And there's a line here. I can follow along with my finger. There's a line where usually cartilage is between there. And between the epiphysis and the regular part of the bone, there's cartilage, okay? So that's what this picture is showing here. You see, this clear thing is the cartilage, okay? And cartilage shows up darker, like it says on the x-ray here. So if it's not fused yet, then you know that this person's still growing. But in this picture, just looking at the top part, so here you can see it's not fused either right here. But in this picture, you see how you don't see any clear part? So that means this is fused. So this person's done growing. All right. And so I have growth like tables where you can see like at what time certain bones stop growing that we're going to look at in class. So again, when there's still cartilage showing, the person's still growing. And when there's no cartilage showing, the person isn't. Now, I will tell you, there's certain things you can do. Like a lot of people will get x-rays like this to see, are they still going to grow taller? And that's how you can tell. Okay. Some people get an x-ray of their hand to see if they're done with puberty. Same type thing. Again, you're trying to see, is it fused or not? Okay. All right, so here's what I was talking about. So let's take a look at this bone here. Here's what they'll ask. Do we have any, is this completely fused? Does it look like it's completely fused? Okay, and I would say no, I don't think it looks completely fused. Hold on, did I have a chart? Oh, it's right here. Hold on.